Hello dear students, I am Dr. Anita Kahar and today we will be studying about the second part of silver amalgam. In the first part of silver amalgam, we have studied about the introductory part of the silver amalgam, the classification of silver amalgam, the composition, the role of ingredients, manufacturing methods, indications of silver amalgam and the various symbols that we are using today in our different amalgamation reaction of different types of silver amalgam. In today's part, we will be learning about the amalgamation reaction and its microstructure of low copper silver amalgam, high copper silver amalgam, and in high copper silver amalgam, we have admixed type of high copper silver amalgam and single composition high copper silver amalgam. Before moving to the amalgamation reaction, I just wanted to briefly go back into the first part where I have told you different symbols, because the importance of symbol is very much while writing the setting reaction or the amalgamation reaction, because if you don't know the chemical formula of different phases, you cannot write the amalgamation reaction properly, and these are not much difficult. It is very important and very simple. So first phase is a beta phase, which is composed of silver and tin. Second is gamma phase, that is Ag3Sn, silver tin. Gamma 1 phase, silver mercury, Ag2Hg3. Gamma 2 phase, tin mercury, Sn78Hg. Epsilon phase, that is copper tin. Eta phase, Cu6Sn5. And silver copper eutectic phase, which is very, very important, that is AgCu, silver copper. Now let us see the low copper alloy. Now the other name of low copper alloy is conventional amalgam alloys. It is also known as GV Black's alloys. So if the long note question asked on a composition and amalgamation reaction of conventional alloy, either GV Black alloys or low copper, the answer will be the same. Now the composition of low copper alloys are, the main ingredient of course is your silver, that is 63 to 70% by weight, tin 26 to 28%, copper 2 to 5%, and zinc 0 to 2%. Now here if you see, the concentration of copper is about 2 to 5%. If you remember, in the first part we have seen the classification based on the copper content, where we have divided the amalgam into low copper alloys and the high copper. So if the concentration is below 6%, it is considered as a low copper alloy. So here you can see it is below 6%. Now, what is amalgamation reaction? We have seen in the first part only. So, amalgamation reaction, it is a process of reaction and setting when mercury is mixed or amalgamated with any alloy. Now, in our case, the alloy is silver alloy. Now, in low copper convention silver amalgam, if we see the reaction, in the first part, either it can be of low copper or high copper. The introduction that you will have to write briefly before writing the amalgamation reaction, you will have to write about little bit about the trituration, because the amalgamation process will start only when the mercury will diffuses into the alloy powder. As you know, silver alloy powder, it is coated with a fine layer of oxide, so that it prevents the oxidation of the components of the silver amalgam. So to dissolve, to get penetrate mercury into the silver alloy powder, this oxide layer will have to be removed. So how it will be done? So trituration is the process in which trituration is done in a two method, either hand trituration or a mechanical. Now in second year you will be using in your preclinical classes mortar and pestle, that is hand trituration for manipulating the silver amalgam. So what does this procedure does? In mortar we take the silver alloy powder and mercury we will take, and after this what we do, we move the pestle. So that what does this pestle do? We move the pestle, and of the alloy powder get abraded against the wall of the mortar. So because of this abrasion, this layer, outer covering that is coated on the silver alloy powder is get removed because of the abrasion, and after that mercury can diffuses very nicely into the silver alloy, and this will start the reaction. So on mixing the alloy powder and mercury diffuses into the powder particle. Now the alloy structure of the surface layer is broken down and the constituent metals undergo amalgamation with mercury. Means the alloy structure of the surface layer is broken down, means the oxide layer get broken and this metal get directly in contact with the mercury and the reaction will get started. Now the mercury has limited solubility for the silver as compared to tin. Silver having solubility of about 0.035% as compared to tin, which is having 0.6%. And because of this solubility, less solubility of tin remains in the solution for a longer period of time as compared to the silver. So as the solubility exceeds the weight percentage, silver first start to precipitate. As its solubility less, it start to precipitate first as compared to tin, and there is a formation of gamma 1 phase, that is silver mercury phase. After this, there is a formation of gamma 2 phase also, means tin will also precipitate and there is formation of tin mercury. Then the remaining mercury, as the time goes on, the remaining mercury dissolves, gamma 1, gamma 2 particles are continuously forming, and these crystals, they start to grow and they impinge on one another, and after some time amalgam begins to harden. Now there are certain alloy particles are remain in the structure which are unconsumed particle, means all this mercury was used up in formation of gamma 1 and gamma 2 phases, and these particles have remained unconsumed, means they did not get the mercury because of the insufficient mercury present in the structure. So these unconsumed particles are present in the set amalgam, and that is around 27% are present in the set amalgam. So how is the reaction that we will have to write? So the reaction is very simple to write. You can see here Ag3SN, that is silver tin, mercury. Now the silver tin, the silver as we have said, silver precipitate first and there is a formation of silver mercury gamma 1 phase. After that, there is a formation of gamma 2 phase, that is with the help of tin precipitation, and these are the unreacted gamma particles which are remained in the reaction because of the non-availability of mercury. If you see the strength of these phases, gamma phase is the strongest phase among gamma 1, gamma 2. And gamma 2 phase is the weakest phase, which is more prone to corrosion. In differences, when differences are asked between the low copper and high copper, so this is a very important point. Because of the gamma 2 phase, low copper amalgam are more prone to corrosion. Hardness of the phase, depending upon the strength, gamma phase is the strongest, after that is the gamma 1, and lastly is the gamma 2. Now the importance of this unconsumed gamma particle is that the unconsumed gamma particle contributes to the strength. It contributes to the strength of the set amalgam only when they are bound to the matrix. Means it should be present in your set amalgam only. So this is very, very important. It is giving you strength when it is bound to the matrix. So this point is very important while writing. Now the microstructure of set low amalgam, low copper amalgam. How it will be seen when you will see in the cross section. So whenever the microstructure is asked, you will have to write about the core and the matrix. The core is formed by unreacted gamma particle. You can see in this picture, you can appreciate this is the regular shaped particles. These are unreacted gamma particles. And the matrix, the surrounding area of this core structure is formed by gamma 1 and gamma 2 phase. Gamma is the all this continuous, you can see this little grayish color, and this is a irregular shaped particle. They are the gamma 2 phases. So this is the microstructure of set low copper amalgam. This is there are various pictures I have seen, but I think this was the simplest picture to understand, which is taken from the book Manapalli. Now coming to the high copper alloys. Now the high copper alloys, they are introduced by the two scientists, that is Udlis and Ines, in 1963, and they are very important because of having the improved mechanical properties, resistance to corrosion, and better marginal integrity. Now there are two types of high copper alloys. One is admixed alloy and second is single composition alloy or unicomposition alloy. Let us see first admixed alloy. Now the composition of admixed high copper alloys powder is silver 69%, copper 13%, tin 17%, and zinc 0 to 1%. Now here again see the percentages of copper. This is high copper, that's why the percentages should be more than 6%. So this is 13%. Now let us see how the admixed alloy is made of. Now the admixed alloys, as the name suggests, it is combining the two shape of the particles. Now there are two shapes available, lathe cut and the spherical. So in this combination admixed, there are 2/3 of the lathe cut particles are available, that is silver tin, and 1/3 is a spherical alloy particles, which is silver copper eutectic alloy. Now what do you mean by eutectic alloy? Eutectic alloys are those which exhibits complete liquid solubility but limited solid solubility. And the most popular example is silver copper. This can be a MCQ question. The most common example of eutectic alloy is silver copper. Now silver copper are more strong and they act as a filler and increases the strength. Now the reaction between the admixed alloy with the mercury is, now again the procedure will start same, that when amalgamation reaction will start, when we do the trituration, it removes the oxide layer and then the mercury dissolves into the silver alloy powder. Now here the reaction occurs in 2 steps. We are seeing the single reaction in a low copper amalgam. Now here it is a combining of the 2 steps. Now if you see the first step, it is same like your low copper amalgam alloy reaction. Now here this is our low copper reaction and this is our admixed high copper alloy. Now here if you see the differences between the 2 reactions, only one thing added is our eutectic alloy, that is silver copper is added here. Okay, so the reaction will be similar when the mercury is triturated with the silver alloy powder. The silver tin from the gamma phase, they start to dissolve into the mercury, and silver copper eutectic phase, from silver copper eutectic phase, silver start to triturate with dissolve into the mercury. So there is a first formation of gamma 1 phase as in our low copper also. Silver copper, that is gamma 1 phase. Tin will precipitate and there is a formation of tin mercury phase, that is gamma 2 phase, same as your low copper alloy reaction, and these two alloy remain as an unreacted, silver tin and silver copper. Now meanwhile what happened, the silver copper eutectic phase, this silver copper eutectic phase, it generates the second reaction. The newly formed tin mercury, that is the gamma 2 phase, it react with the eutectic phase. It react with the eutectic phase and it forms eta phase. Means here the newly formed gamma 2 phase, it reacts with the silver copper eutectic phase and there is a formation of copper tin, that is the eta phase, and the gamma 2 phase get eliminated completely and there is a formation of silver mercury, that is the gamma 1 phase also occur. Means the second reaction is as the gamma 2 phase, the tin mercury reacts with the eutectic phase and there is a formation of eta phase. So this gamma 2 phase gets eliminated and also in addition there is a formation of silver mercury, that is a gamma 1 phase. Now these eta phases, they are found, these are formed as an halo around the unreacted eutectic alloy. Silver copper, around the silver copper, unreacted silver copper eutectic alloy, this copper tin, this eta phase is formed as a ring, as a halo zone around the unreacted silver copper. Now this eta phase will form only when there is a copper concentration is above 12%. then only this eta phase will be formed when the net copper content will be 12%. At least 12% should be there copper percentage, unless the eta phase will not be formed. So moving to the microstructure of set admixed high copper amalgam. Now, as we have seen in the low copper amalgam, the core was made by the unreacted gamma particles. The reaction was very simple. Now here there are two unreacted products that have been formed, that is unreacted gamma and unreacted eutectic phase, silver copper, and also in this eutectic phase it is surrounded by a halo of eta phase. So this will be your core. Whatever the unreacted has formed in the reaction is your core, and the matrix is gamma 1 phase, because there is no gamma 2 phase is formed, so the matrix is formed only of gamma 1 phase. Now here in this pictorial image you can see the core is, these are the regular crystals, they are of your gamma phase, this your unreacted gamma phase, and you can see here the halo, this is the halo of eta phase, white ring, and the black circle is of your eutectic phase, that is silver copper. And lastly is your matrix, that is the light gray in color. This is whole matrix formed by the gamma 1 phase. So this is about your admixed high copper amalgam. Now let us see the single composition high copper alloy. Now in single composition high copper alloy, the best example is a ternary alloy in spherical form. Now unlike the admixed alloy, each particle of the single composition alloy powder has the same composition. Therefore, they are called as single composition or the unicomposition. And the best example is ternary alloy in spherical form. So the concentration is silver is about 45 to 60%, tin 50 to 25% of the copper content has again increased. In admix it was about 13%. It is now in single composition it is around 13 to 20%. Zinc is 0% and indium or palladium is added in a small amount. Now as I said, as compared to admixed alloy, each particle of single composition alloy powder has same chemical composition. Every particle has all the phases. Every particle has all the phases. It includes the beta phase, gamma phase, epsilon phase. Some manufacturers also add the eta phases also. Now epsilon phase is added to provide the additional copper. Now the reaction here, the setting reaction is differ little bit from the admixed alloy. Now in admixed high copper we have seen two reactions, but here there is only single reaction. And how is this reaction differ? Now when we triturate mercury with the alloy powder, the silver tin from the silver tin phase dissolves in a mercury, whereas copper dissolves in a very negligible amount from the epsilon phase. Okay, so there is a first formation of the silver mercury phase, that is gamma 1 phase. Now instead of forming the gamma 2 phase that we have seen in admixed alloy also and in a low copper also, so here this tin contributes to the epsilon phase, and this epsilon phase get converted into the eta phase. Okay, so this is very important, okay, that in the initial stage of reaction only the tin is used up in the formation of eta phase. Hence there is not at all formation of the gamma 2 phase occurs. So this is very important, and the remaining part is unreacted silver tin and copper tin. And these eta phases, as in admix we have seen, they form an halo around the eutectic phase. But here they are formed as an rod shape, which are embedded in the matrix of gamma 1. So this is the setting reaction of single unicompositional alloys. Now the microstructure of set unicomposition high copper amalgam. Now here there are formation of so many unreacted phases. So the core consists of, set amalgam consists of a core particles of unreacted gamma, beta, epsilon phases, and which is surrounded by a mesh of rods of eta phases. Now here you can see in the picture, you can see this bigger circle which is showing all the unreacted gamma phases there, beta phases there, epsilon is there, which is surrounded by, these are the rods of eta phases which are present in the matrix. And the matrix is formed by the matrix is formed by the gamma 1 phases. So this is about the microstructure of your high copper amalgam, single composition. Now here these are the three pictures I have kept here just to differentiate between the three amalgams, that is low copper, high copper admixed and high copper unicomposition. Now in this picture, if you see the core and matrix, in low copper the core is formed by unreacted gamma. In high copper admixed, core is formed by again unreacted gamma and unreacted eutectic, around which there is a halo of eta phase. So this is core. In high copper unicomposition, unreacted alpha, beta, gamma, epsilon, gamma, alpha phase, beta phase, epsilon phase, and these are the eta rods of eta which are present in the matrix. And the matrix which are formed in low copper is, it is of both. Now the gamma 1 matrix is common to all. Only addition is gamma 2, that too in a low copper, because it forms in that reaction. Because in high copper, in both admixed and unicomposition, there is elimination of gamma 2 phase there, so there is no gamma 2 phase at all in the matrix. So only matrix of low copper is formed by gamma 1 and gamma 2, while in admixed and in unicomposition, the matrix is formed by the gamma 1 phase only. So I think this is the simplest way to keep it in mind, the reaction, setting reactions or the amalgamation reaction of all these three types of the amalgam, which are very, very important for the exam point of view, because most commonly asked long answer question is on silver amalgam is this only. So the expected question on this topic in today's part, it is define the term amalgam and write in details the composition, role of ingredients, and setting reaction of conventional or high copper admixed or high copper unicompositional silver amalgam. So this is very, very important question, and you just go through it at least twice so that it will be easier for you to understand it and to write it. Whenever you learn the reaction, you actually try to write it, and then it will be easy to remain, keep it in a mind. So this is all about the part 2. In the third part, we will be watching about the different properties related to the silver amalgam. Till then, thank you.